Test,
Well,
test, test.
But yeah, there's humongous amount of change. It really starts with
Testing, testing.
med students, like college students.
Is this
who are
pinned
just like,
for some
let's
reason?
look
Okay.
at the literature and realize this is a whole bunch of.
All right, sorry, Warren.
And that's
Warren, I don't know how to make it to
the
just me,
Institute of
so you're gonna
Justice
be
Grade, just
in the
like
video with
Jake
your name.
over at Berkeley, who are like.
Yeah,
they
there's just a
actually
class
help
wrapping
get
up,
rid
so
of
we'll give it a few more minutes. Alrighty, I'm gonna test this microphone out for tonight and we'll see how it goes. But welcome everybody. It is 6:40, so I will go ahead and get started and people can trickle in and also watch asynchronously. Cool, yeah, today should be a bit of a shorter meeting because we don't have enough, not enough, we don't have as much last time. So we'll go ahead and get started. Lecture 4, Cloud at California, DCAP for cloud computing. Sounds good. Ooh. Here, I'm really bad with Zoom. I haven't done this in a while, so here, I'll just keep myself as talking. Okay, cool. Alrighty, let's get started. And feel free to drop any questions down below whenever you have them, and someone will be able to answer, or I'll see the chat. So today's agenda, we are going to be covering a little logistics and then also be covering computing services and applications within AWS. So quiz 2 and 3 were actually released earlier this week on Sunday. They're little simple B-Courses quizzes, 10 questions each, and you can find all the information, the slides, and the recordings. They'll be due tomorrow night at 12 a.m. or midnight basically, and should be pretty doable. And let me know if there's any questions. We'll finalize, or let me finalize how quizzes are going to be released. So after every lecture, we'll be releasing the quiz the following day or before, and they will be due before lecture of the next week. So today, quiz 4 will drop, and then it'll be due the following week on next Thursday. And another thing we decided to finalize is we're having asynchronous lecture participation. So if you have like a sick day or need a mental health break or things like that, or you just don't want to show up to class but want to do it a different day, you can fill out the Google form with the same secret word that you see within the recordings or the slides, and we will be providing you participation for that. Whether you actually did the slides or went through all of them, that is at your discretion. We're just hoping that you can get the most out of the slides as you can. And yeah, the Google Forms will be within every slide. And then we're going to be diving into computing services and applications. So last week we did cover a lot of security practices and security services within AWS. So things like CloudWatch, CloudFront, all of those things that are more security oriented and network oriented. Today, we're going to be actually talking about things that are going to be running your applications and a little bit beyond what you typically hear, like Amazon EC2, the virtual machine service, and S3. So that should be exciting. And let me know if you have any questions along the way and I can answer those. Cool, let's get started. So applications. So this service is actually probably one of the more commonly used ones. It's very versatile and it offers a lot of range of functions. So Lambda is essentially a serverless service that allows you to run code for a certain type of application. When you think of Lambda, you should think of something called a function. So it's something that doesn't necessarily take a lot of computational power to do, but is able to accomplish some kind of task or some kind of process. So for example, you can actually write, this is just going off the top of my head, but you can write like a function in Lambda that adds 2 numbers. And you can think of it as something that's not necessarily very computationally heavy, but it accomplishes some tasks like adding 2 numbers. Lambda functions can be triggered by events, which can be linked to other services within your AWS environment. So let's say you have some kind of event that happens within one AWS service that can trigger the Lambda function, and then the Lambda function can trigger something else. So what I mean by that is, let's say you have an S3 bucket, you can trigger based on, like, let's say you created an S3 bucket and you added something in it. By adding something, you can create like a trigger that sends information to the Lambda function, and the Lambda function does something with that thing you just uploaded. One example Lambda is really good for is compression, or doing something, reprocessing images. It's really efficient in that manner, since it's not as computationally heavy as like running a full application like EC2. But say you uploaded a photo and you want that photo to be processed in some way, you can set up an event that says, when a photo is uploaded, I want to send this photo to AWS Lambda, have that Lambda function process the photo, and then the Lambda function can send that photo to like another bucket, for example. So that's just one use case. It supports pretty much all the main coding languages or libraries. So you can write Lambda functions in Python or in Java, and even Node.js. And all of the code is ran on the AWS compute infrastructure, so you're not using any of your own hardware at all. It's all in the cloud. The charges are a little bit more flexible. In the free tier, you have, I think couple up to like 1 million Lambda calls, I believe. I'll have to double check on that, but you're typically beyond the free tier, you're charged with the number of requests and the request time. So how long the Lambda function runs, and then how many Lambda functions you've triggered. And the more Lambda functions you use, you actually have a savings plan associated with that. So if you have a lot of Lambda functions that are consistently being used, they have packages that allow you to save money. And yeah, we'll see how to kind of incorporate Lambda in some of our other services. I have the demo at the very end, but yeah, that's a brief overview of AWS Lambda. This is going to be probably very versatile. So it's one that typically most cloud users are familiar with. So it's important to kind of soak it in. Cool. And then our next AWS service is something called AWS Batch. So what a batch is in general software engineering or software computing is, let's say you have a lot of objects that you want to perform some kind of operation on. You don't want to necessarily compute every single object, like you don't want to perform that operation on every single object one at a time. So going back to like the image processing example, let's say I have 1,000 images and I want to process it or resize it. I don't want to go through every single image and reprocess it or change its size. So this is where AWS Batch comes in. Batch computing basically allows you to run some kind of operation on an entire batch or a big group of objects. So AWS allows you to do that, and it also provisions the compute resources that you need. So you don't have to worry about CPU performance or the necessary hardware to do so. And it's part of the integration within Batch, but it can create EC2 or Fargate Spot instances. Fargate we'll get into a little later, but just know that you can, it handles most of the processing aspect of performing a function for you. Yeah, and with this bullet point, you can have data within an S3 bucket, for example. You can upload a schedule that says, okay, at this time, I want everything in this bucket to be processed a certain way, or I want to perform a job, which is stored in the job queue. For example, resizing images or reprocessing images. And then you can put that into Batch, and then it'll handle that for you. So it'll, at this time, perform a resize operation on all the elements in this bucket, and you don't have to worry about any of that. You just have to assign it a schedule and a job. And there's no additional charge. You only have to pay for storage and compute resources. So very versatile as well. And it's very utilized in situations where you're working with objects that are in mass quantity. Alrighty, light sail. So we went over EC2, right? EC2 is a virtual machine that lets you essentially have your own server in the cloud, and you can run computations and build your applications within that, and it handles all that processing for you. Lightsail is like the light version of that, like LITE meaning. So it's like a smaller version of EC2 where you don't necessarily want to use so much computational power and hardware to do something. So you would choose this service instead. So it provides a VPS, or virtual private server instances, and they have everything that you would find in EC2, including containers, storage, load balancing, and then databases. So it's perfect for building like a personal website, for example. You don't have that much going on in your website. Your website is not something to the scale of like Amazon.com. So you don't want to go to EC2. You can do it in Lightsail. It integrates with a lot of pre-configured sites like WordPress. WordPress is really good for developing web applications. And as I mentioned, it's similar to EC2, but made for cheaper and quicker tasks. You can have a choice of having it being hosted in a Windows or Linux server. So it's a little bit operating system dependent. So you got to keep that in mind when developing your web app, for example. And it includes its very own IP address and SSH access. So that's where you can have a lot of traffic come in, and it'll handle that through Lightsail. And every resource has a cost associated with it. So you do pay for whatever resources or instance you use. Any questions so far? Or anybody in Zoom have any questions? Perfect. Alrighty. And then next is API Gateway. So last lecture, I did mention a brief overview of what APIs are. It's like ordering something from a restaurant. You don't necessarily know how the chef is going to cook it, but you're getting something in return just by requesting it. That's what APIs are. And API Gateway is a service that lets you set up APIs and create APIs. So you can create a menu, or you can handle those kinds of orders as an analogous situation. But in APIs, there's actually three different main styles of APIs, essentially. We'll get into this. So HTTPS APIs are when you request something over the internet, right? When you type in HTTPS and then google.com, that's an API request to grab the Google web page. So the front-facing web page that Google has, when you type in google.com, it's an HTTPS API request. So you're getting the website from Google servers. So that's an example of an HTTPS request, and that is one form of API. REST is a little bit more of a structured architecture in regards to requests. So in a REST API, you have four main operations. We touched on this in last lecture, but the four operations are get, post, and then I'm not too familiar with all of the API, but you should know that it's get, post, update, and delete. And update might have a different word for it. I don't know off the top of my head, and I apologize. But if you have any, if you know what it is, you can drop it in the comments. And yeah, it's just a structured architecture of API requests. And so when you're building a web application and you want to build an API that lets a user access something within your server or from a database, REST API is a way to set up a frame or an architecture for that. So you have the four main components or the four main requests, and you can build your API off that. And the WebSocket API is a bi-directional communication between client and server. It's not too important for general sake. It's mostly used in situations where you need instant feedback when you perform an API function. So for example, if you created a web application that has a chat feature, right? When you send a message, you're sending a post API request. And then when someone responds, they are also sending a response back. So there's that bidirectional connection between you and the server, you being the client. And yeah, API Gateway has functionality that handles all three of those API. And it allows you to handle traffic based on API requests. You can kind of see the metrics of the traffic you're getting and the number of requests within a given time frame. And you pay for every API call, usually in tens of thousands to millions of requests. And it depends also on the size of the data transferred in and out. But it is very useful when you need to build a web application that has a lot of functionality where you need to interact with a client, or the client needs to interact with your site. Next, we have Global Accelerator. This is a little deviation from API, but Global Accelerator is going a little bit back to the network aspect of AWS. So when you have a lot of customer traffic and they're trying to access your site, they might be living in different regions of the world. And you want to make sure that latency is as best as possible, so they're getting the correct responses from your site. So when a website is very congested, Global Accelerator allows you to move the traffic to edge locations. And within these edge locations, you have entry points that when you're trying to access the application, it can go through the entry point and then into your application versus going from the client to your web server. So what I mean by that is, instead of the traffic going directly to your web server, Global Accelerator has edge locations that store these entry points that a user can go into these entry points, and then it'll take that to the web server. So it increases latency, and your users across the world will be able to access your site in a timely manner. And you can have multiple IP addresses for that. So it's per hour, and it also depends on how much data is transferred over the global network. So there's a premium associated with that. And here's a visual to kind of explain what I mean if my words were not clear. Here's your application. Let's say your EC2 instance in the UK. And then you have a lot of users across every continent trying to access that web server. Well, that's without Global Accelerator. Well, if you implemented Global Accelerator within your stack and application, you have these blue lines right here. These are the edge locations of AWS servers. And then instead of these users connecting directly to the web server in UK, you can actually connect to the entry points, which is very quickly, very fastly responsed, or you get faster responses. So a lot of seamless connectivity between users. And that's why edge locations are very important within AWS. You have access globally. So no one is discriminated against geographically when you're building your web applications, since AWS is all over the world. Next, any questions actually, because that one is a bit of a complicated one. Alrighty, sounds good. And then Elastic Container Service. So in lecture 2, when Arun was kind of diving over what a container is, I can give a brief summary of that. So when you're building, let's say, some kind of program, and you want to be able to deploy that program in different machines, like in the cloud, for example, or across different hardware, you want to store that, you want to be able to have it deployable and have it be versatile. So it should be independent of whatever operating system a hardware has or things like that. Containers are essentially a way you can do that. You can package something you've written into a container, and then you can deploy that container. So let's say I wrote some program in Java and I have a bunch of libraries with that program, things like that. You can package it within a container, and then you can run that container by deploying it in servers or your own computer. So that is a container. And ECS, not to be confused with EC2, Elastic Container Service, is a way for you to store containers. And it's also compatible with Docker, which is more of like a container development tool. You might be familiarized with it already, or you will be when you get into the industry. Docker is a program that lets you kind of work with building applications and the like within the container world. So yeah, EC2 or ECS usually is integrated with EC2 or Fargate, which is another service I'll get into. So you have these packages of programs that you want to run, right? ECS allows you to store it, and then you can use it when you're transferring those packages to a virtual machine or an EC2 instance. So that's what launch type means. EC2 launch type means like what is going to be processing or what is going to be running those containers. And then the tasks are usually written. Task meaning what components make up what part of your application. So let me rewind a bit. If you have a very large application, you have a lot of different sub applications that need to do different features or functions within your main application, and those are stored in containers. Tasks kind of specify which containers do what within your entire application. And then, yes, Kubernetes is tied in a lot with container services because this is your orchestral tool. So what is Kubernetes? Well, Kubernetes was not developed by AWS. It is very popular and it's used throughout the industry when running containerized applications. Kubernetes is actually developed by Google, side note, but it's an orchestral tool that kind of manages how your containers back up and function in the grand scheme of things. So to provide an example, if I built a web application and I have a container that handles, for example, like a chat feature, a container that handles like a marketplace, and then another container that handles like user data. Kubernetes is a tool that manages that when your application is fully running. So let's say my user data container requires a lot more computational power. Kubernetes can duplicate the container to give you more computational power. And it's used in that sense where it's orchestrating a lot of different microservices. And microservices are a whole nother topic on its own, but they're not it's not necessary to learn in this class, but it's something to look into if you're interested in Kubernetes and containerized data. So yeah, and then EKS. So I was just talking about Kubernetes, like what Kubernetes functions as a whole. And then EKS, or Elastic Kubernetes Service, allows you to run Kubernetes within an AWS environment. So like you can have clusters or like groups of machines running containerized data in a virtual private cloud, and you can kind of control access within that, and you pay per cluster and pay for the computational resources. But you won't be able to, you shouldn't be able to look too far in, or excuse me, let me rephrase that. You won't have to worry about getting too familiar with this service. Kubernetes is just another topic on its own, but it's very important in the cloud space. And all you need to really take away from these two is that containers are a more versatile way of deploying your applications across different servers or different hardware. And then Kubernetes is a way to manage those containers within the entire picture and allows for things like backup or recovery when one container fails and the other one needs to get more resources. And then AWS EKS is an environment where you can run Kubernetes. Any questions? Fantastic. Okay, and then Fargate, this is I can provide like an analogy. If you have a regular application and you run it in EC2, Fargate is the EC2 for containerized applications. So what I mean by that is Fargate is specifically dedicated to containers. So when you have your applications that are divided up into containers, Fargate is the EC2 equivalent of running those containers. And so, yeah, it's a serverless compute engine built for running those kinds of data. And you only pay for the resources that you use, similar to EC2. And if you look at the graphic here, if you don't integrate Fargate, right, you build like a container image just means like code. If you build a container, right, you deploy it within EC2 instances, and then you kind of have to manage all the computation associated with that. Some containers require more resources than others. And then you have to actually isolate those within different virtual machines if those containers require dependencies within each other. And then then you run and manage that all at the same time. It's a multi-step process to do something that you want to do, and you also have to pay for the resources that you use. With Fargate, that takes a whole 2 steps out of the process and saves you money. So you can build a container image or some kind of code within your application. You can determine how much this container really needs to perform, and then you can kind of run it from a higher level view and just pay for whatever resources that you need. So yeah, Fargate is analogous to EC2 when you're talking about containerized data, and it's even better for that use case and saves you money over time. Cool. SNS, AWS SNS. So this is more computation. Now we're going to get into 2 kind of queue-like services, and I'll get into what I mean by that. So SNS, what does that stand for? That stands for Simple Notification Service. So let's say you have an application and you created like a newspaper, a virtual newspaper, where you're sending an email or a newsletter to all your subscribers every morning. This is a perfect use case for SNS. SNS is a fully managed messaging service. It allows you to send a lot of messages all at once in single request. It supports things like text messaging, emails, and even mobile push notifications. And you can integrate this within AWS Lambda to set triggers when these messages go out. A topic is essentially a category, a standard topic. So a topic is just like what people are subscribing to, if you look at it that way. And then FIFO, first in, first out, meaning if you have messages that are put into a queue. So like, let's say I wrote a bunch of newspapers and I want one to be delivered Monday and then Tuesday, Wednesday, you can put your newspapers in that order and they'll be delivered in that order. So first in, first out, what comes in first gets sent out first. And then you pay for notifications sent and every API request associated with accessing that. Let me double check. I'll do a brief overview of SNS. Let's see. Does text message verification, like for 2-factor authentication, use SNS? Yes, you can actually integrate SNS for 2-factor authentication, and you can set triggers. I'll get into this in our demo, but you can set triggers with an AWS Lambda. So like if you try to log in and your Lambda function can detect that you're logging in, you can send an SMS that goes directly to your phone or something, and you can verify through that. So yeah, good thinking outside the box. SNS is a great use for that. And so going back to my example of like if I had a newsletter, you could set up a topic, or let's say, remember I said topic is like what subscribers subscribe to. So I can have like a topic that says newsletter. I can set up subscribers, put in their email in SNS, and then every morning I can send out a notification through SNS that comes in the form of like a newsletter. So yeah, it's pretty cool and very useful. You can do a lot of cool things with this, and you apply it to a lot of different use cases. And we'll get into that in our demo. I'll show you exactly how to use SMS. Cool. And then SQS, it's not directly related to SNS in the way that it's like a messaging service, but it is related in the queue aspect. So SQS is like a fully managed queuing service, or anybody that subscribed, or any resource that subscribed to SQS, your SQS like instance can pull the message. So let's say I built like a web application that processes, that's a marketplace, right? And you're selling a bunch of goods within that marketplace. SQS is a way to handle all of those sale orders and then process them in orders. So what I mean by that is, let's say you have 3 items that all got sold on the same day. You want to process the orders in the order that you got the order in, right? So like you got one in the morning, afternoon, and at night, you want to be able to process that order in that order. So SQS just puts, you can integrate this within like an application, and it puts an order, for example, and then it sends out a message to you or to another feature of your application with that given order. So the first order that comes in gets processed first, and then that way you're guaranteeing that your application is running smoothly in a first in, first out manner. And it's not just for something like sales orders, you can do it for a lot of things and even messages. But one of the biggest use cases for SQS is like sales orders. You want to make sure things are processed in the order that you receive them, so no customers are, unfairly treated. So you have SQS to handle storing transactions within a queue, and then getting those transactions and processing them in the order that they came in. So yeah, and you pay per request and the size of the request. Sometimes, like going off of the SQS example with like a sale order, you have sale orders in your S3 buckets that are in the form of like JSON files. So like, let's say it has metadata that says user purchaser name, purchaser amount, and then you want to process like an order based on that. You can integrate it with S3. So SQS takes in that JSON file and then process it before it processes any other order. So yeah, that's just one use case. Any questions? Okay, cool. And then last but not least, we have Amazon Connect. This is a more human, I guess. And what I mean by that is it involves humans. So this is a service where you're actually working directly with people, not machines or hardware. So this is a cool feature, and Amazon has set up a really nice system that handles this service. But what Amazon Connect is when you have a big business and you want to create like a tech support center, or you want a way to handle customers or handle customer requests or questions, Amazon Connect is a service that you can integrate within your application to actually do those things. And that's pretty crazy when you think about it, because Amazon is using real humans to work on your application and handle the tech support side of things. So yeah, it's a cloud contact center. So it's tech support for your customers. You can sign up for this, and you can train a whole bunch of agents within 20 minutes. It handles a lot of that. You need to tell them what you're trying to do, give them some kind of methodology of like, this is how you respond to these kinds of requests, things like that. And Amazon handles everything else. They'll train the agents, and you have a full running AWS cloud contact center. So yeah, within Amazon Connect environment, you have the customers, the people that need to speak with an agent or a customer service representative, and then you have the agents themselves, which are hired through Amazon. And don't know too much about the specifics on how they hire them, but just know that there's real people working on the other end. And you don't necessarily need to use real people as well. Amazon Connect is a really big service. You can have chat bots, for example. So when you're online and you're going through like PacSun or Gap, and then those things that pop up and it's like, hi, how can I help you today? Or like, what are you looking for today? Those aren't real people. Those are chat bots. You can actually set that up within your application with Amazon Connect. And those chatbots use machine learning to kind of detect your sentiment, your kind of requests, and then process them accordingly to how you want those processes to happen. And then there's something called Contact Lens. When you're working with real agents, Contact Lens is a service that detects your voice through the phone line. So if you call in as a customer, Contact Lens takes your responses and processes them and does some kind of machine learning, and that data better helps train agents. So let's say your application has like a hotline for your customers, and your customers call in, and then a majority of the customers call in for complaints. Contact Lens is actually able to detect that and see like, wow, this hotline is getting a lot of complaints. Let me do some machine learning and kind of determine where the source of the complaints come from. And then that data can be used to help train your agents and also help you figure out how your customers are feeling. And yeah, there's a free tier. You have a limited range of free calls, messages, and tasks, and then you pay as you go and usage per minute. We don't expect anybody to really get involved with this service right now, but if you become really successful and you have your own business, Amazon Connect is a perfect way for you to outsource the tech support side of your business. And you can kind of save yourself a headache of finding agents and finding a call center and doing that and the like. It's pretty cool. You have the ability to transfer human labor into the cloud. Yeah, the cloud is pretty cool. And then any questions? I'm actually going to move on to the demo now. So if you have any questions about the slide, now is the time to ask, and I can provide some clarifications on any services. Alrighty. Well, if you have any questions, feel free to drop them in the chat below and I'll help answer them. But we're going to go into a demo, and this is a pretty cool demo. It's very applicable, and you can kind of see what I mean by some of these services. So today we're going to be demoing an integration between S3, Lambda, and SNS. So let's suppose this is a use case that you can use this integration for. So let's say you have an Amazon S3 bucket and you store a bunch of really important things in there. Like you have your birth certificate, you have legal contracts, and you have like policies for a company, things like that. Stuff you don't want people to change or delete. This would be an example when you can use this integration. So yeah, let's say you have a bucket full of important goods. You want to set up a system in which you're notified whenever something is changed within that S3 bucket. So you want to get an email every time something is updated, deleted, or created, just so you can kind of oversee what happens in that bucket. You can use AWS S3, Lambda, and SNS as an integration to detect those changes within S3, get a notification about those changes, and now you're always aware of what's going on. And you can kind of see what kind of progress is being made within S3, or like If you don't want anything to touch, anybody to touch whatever in your S3 bucket, you will be notified when someone does, so you can go fire them or, kick them out of your family or something like that. Cool. So I'm gonna go ahead and, oh, 1 second. I'll give you those, the attendance form in a second, but alrighty. Cool. So I'm gonna log into AWS. I'm gonna put the microphone down and I'm gonna start using my real voice. Okay. So first thing we want to do is we want to create our S3 bucket, right? This is where we're going to be storing our really important information. So what we do is we create, I'm logged in. So, but before this, you would log into your Amazon account. But you guys are smart enough to know that. But we're going to create a bucket. Let's call this S3 important stuff. We can kind of skip over like the permissions or all the other details when creating this bucket. But for now, we're just going to create a bucket called S3 important stuff. This is where we're going to be putting our really important information that we don't want anybody to touch. And if they do touch it, we'll be notified of that. Okay, so we just created our first S3 important stuff bucket where we're going to be storing our important files. Now, we're going to set up the SNS aspect of this demo. So you can see right here, I clicked on, you can type it in here as well. I have it bookmarked, but simple notification service. It's a perfect site, perfect service for you to do notifications and set those up. We want to do something called create a topic. Remember, topic is something that users subscribe to. So I want to create a topic and then integrate that. As you can see, it's a first in, first out as standard. But I'm going to just hit standard right now for the sake of simplicity. And let's say in my topic, I'll just call it topic changes. So you want to be notified of changes. You just have that, name that, and then you can kind of skip all the other pieces right here. We'll go ahead and skip that. And now you have your topic, the things people subscribe to. Well, I want to be able to see what goes on in my S3 bucket. So I'm actually going to be a subscriber to this topic. So we can do something within this topic called create a subscription. You can kind of set up what kind of notification you would like to receive, or you can do things like integrate it within that web application. But for now, we want to receive our notifications in the form of an email. And then what email do we want to use? Well, I want to use my personal email. We'll just say bowenfan@berkeley.edu. So whenever notifications are sent, they will be sent to that email. Right here, it should say create subscription, but the Zoom bar is blocking it. Cool. It actually lets you know that in order to be a subscriber, you have to go to your email and actually click on it. So right here, I should receive a notification that says confirm your subscription. It does this as like an authentication step. So when I click confirm subscription, oh, that was an older message. This one. Cool. Subscription confirmed. So now I have access to this topic. And then whenever I get notifications, I'll get them through my email. So right now it says status confirmed. I'll receive it through email. This is the email I'll receive it at. And this is the topic or subscription thing that I'm subscribing to. It's name. That's name. Cool. So we have our bucket set up, and then we have our messaging system, our notification system set up. Now we want to create some policies to allow those things to interact with each other. Like, how do you bridge S3 and SNS, and how can you get them to work with each other when they block off all access? So that's why you want to create a policy. So we'll touch on this. Remember, in our first demo, we actually went over, or in our second demo with Arun, he kind of went over policies. So I'll do a brief overview of that as well as I'm going through this. But yeah, we want to create a policy that allows these integrations to work with each other. For simplicity's sake, I have this policy already created in JSON format, so I don't have to write everything out. It'll be in the demo. This is going to be the policy. Yeah. Remember, you can write your policies in JSON format. You can skip like the drag and drop or select drop downs. So here's my policy. What this basically does and says is like, you're allowed to access something within this service. So I have a service for SNS topic name. So we created that topic. It was called topic changes, right? So we could write that here. We can fill it in. But this basically says for these resources, you have all of these permissions that can be attached to this policy. And you'll see why we need these permissions. So next, we'll just go ahead and confirm that and click next review. We'll just call this S3 Lambda SNS policy. Allows access between S3, Lambda, and SNS. We'll just create that policy. So yeah, why do we need a policy? Well, we're going to attach it to AWS Lambda because Lambda is bridging the gap between those two services. So we're going to attach the policy to AWS Lambda that says you can access S3, do something with the things inside S3, and then push that stuff to SNS. So remember, roles are something that gives you permissions at the resource level. So we want Lambda to be able to do something with those services. So we create a role. So we click Lambda, it's an AWS service. And we can attach the policy to our role. And our policy, remember, granted permission to do a bunch of things. So we just attach it to this role. And then we can just call this role Lambda S3 SNS. And you can kind of see autofill's description, but it says it allows Lambda functions to call SNS and S3 on your behalf. So now you have a role, right? This basically means when you create a Lambda function, you can attach that role that allows you to access S3 and SNS. So what's next? We're going to create the Lambda function. And you can kind of see it looks really familiar to writing code. So it's pretty exciting. So we'll call this function detect changes S3. We're going to write this code in Python 3.7 because that's when that's how I looked at the demo and practiced it. So we're going to use 3.3 or 3.7. This Lambda function, we're going to give it the permissions to access S3 and SNS. So we're going to use an existing role right here in the three options. We're going to use existing role. And then we're going to click role Lambda S3 SNS. That grants you the permission to do those things. So now you have this kind of dashboard. You have your function right here, the detect changes S3. So let's write our function. Let me move this. For the sake of time, I already wrote the function out, but let me just copy and paste that over. You can see your function can be written in straight Python, which is awesome. Like it takes a lot of the complications out of, you can see kind of how the cloud serves you versus you serving them. And then, so this right here, we need to fill it in. An SSN or SNS ARN is just basically like what identifies the topic you're using. So what I mean by that is you have this topic, right? And then you want to be able to access the topic. There's something called ARN. ARN is just a unique identifier for this specific topic. So I'm going to copy that, go back to the Lambda function, go to my function detect changes S3, and then copy and paste that unique identifier. So see, target ARN, it's just meaning this is going to be what you're going to be That's going to be your destination. Cool. So brief overview of what this code does. It just basically, given a trigger and an event, it detects, it gets like different parameters within that event, and it processes it in a message, and that message is sent to SNS, and SNS will send that to you. There's a lot of tutorials on how to work with events and write code for that, so I won't get into that too much, but there's a lot of resources online. So yeah, you have your function right here, right? And remember, we talked about how Lambda is a trigger dependent service. So we can add a trigger. Well, what do we want to be the trigger source? We want it to be S3, right? Because we want to detect changes. We have the S3 important stuff bucket that we can select. We have an event type. So we want to detect whenever whenever a bucket gets changed or updated. So I'm going to do all object create events, and I'll create one for all object delete events. So this one just says, anytime you detect that your bucket has been updated or like something has been created within that bucket, it'll send a trigger. And then I'm going to have to do another one for deletes. So whenever something gets deleted within my bucket, I'm going to set a trigger. So right here, all object delete events, boom. And it's cool that you can select multiple triggers. So you can have two triggers right here that both work to trigger the Lambda function. So yeah, detect changes. So whenever we delete something, update something, create something, it'll create this event where it triggers the detect changes function. The detect changes function gets something from those S3 buckets, and then it's going to send it to SNS for SNS to send to me. So on success, so when you detect a trigger, we're going to send it to our topic changes, and we're going to click save. So now we have this three-layer stack of functionality. Cool. So we just completed our Lambda function that has set up a trigger and a destination to send the process, the operation to. Now we'll go back to S3. We'll go to our bucket. And remember, I said we want to detect anything. So let's upload something. Let's upload a really important document. So let me add a file. I have a file called importantthing.json. So just pretend like this is my birth certificate or something. When I uploaded it, I can hit upload. Boom, upload succeeded. What should we expect? We should expect an email, right? Well, let's go to our email. Oh, wow, we got an AWS notification message. This is just more of the metadata on the actual Lambda function, but this is the notification we care about. It says, this email is to notify you that there has been some changes made in your AWS bucket. And it's in this bucket, the change was done with this file name, and the operation or what happened was it was a put, or it was created. And this is the content type, and you can kind of see the content within the file. So that's awesome. Like now, whenever someone creates something within our buckets, or like they edit my birth certificate or delete my birth certificate in like this storage, I'm notified, so I can kind of keep track of what things happen. So yeah, that's an overview. You can use this for your own projects. You can extend this to a lot of different use cases. This is just one example, but you can keep track of what happens within your bucket. So yeah, now this thing is fully up and running. Anytime I do something, let's add a Python function within this bucket, upload, we should get another notification. Let's see how fast it responds. Boom, within a couple seconds. So yeah, that's the demo. Let me know if you guys have any questions, and we'll probably do a lab within the next week or another week after that to kind of let you test things out like this. We'll give you some guidelines, some directions, and you can create a cool project like this yourself. But yeah, this is an example. Hopefully you enjoyed the demo, and if there's any questions, feel free to let me know. But other than that, here is the attendance form. The word is going to be container. A chat. Yeah, so how does the Lambda function get the proper parameters? That's a great question. So whenever you set up a trigger translates to like an event. So when something gets detected, it sends like an array called an event to the Lambda function. And then you kind of use indexing to kind of get the parameters out of the event. So it looks like you can do this, for example, to get some kind of parameter out of it. So like you can get S3 bucket name. Like that's, for example, that's how you access the event. And then you can use that to process accordingly. I actually don't know too much specifically about how events work, but you can look online and there's a lot of resources. But yeah, an event is like an array of arguments that gets passed into a Lambda function, and your Lambda function can access those parameters. Yeah. You can do some cool things with that. Let me know if it's not clear and we can kind of dive into it deeper. But other than that, everybody here is welcome to go, or feel free to ask any questions, and everybody in Zoom is also welcome to go. Thank you guys for showing up and appreciate it. We'll have some more content for next week. Cool. Yeah. Overview of Lambda. So I assume everybody here has the Google form, so I'll post, let me double check. Let me go back to the slides. Yeah, so Lambda is it's a service that allows you to run functions or simple things that don't require virtual machines or like large scale computation. So like, for example, a function like add, right? You take two numbers, you add them together. That's something that Lambda function would be perfect for. It's handling small scale things that don't need a whole computer to do. And you can use triggers to trigger a Lambda function. So what I mean by that is Lambda can be integrated with your whole application and detect something, do something on that detection, and then send that result somewhere. So let me rephrase that. You can set a trigger that triggers the Lambda function. The Lambda function takes the event arguments, or like the things that it detected, and then it can process that however it wants and then send the result elsewhere. That's the use for a Lambda function. So you could have two numbers in an S3 bucket, for example. You can have a trigger that says, when these two numbers are uploaded to my S3 bucket, I want to perform the add Lambda function on those two numbers. So you can write code that says, give me those two numbers, let me add them together, and I'm going to send that result to, like, let's say an S3 bucket or something else. But yeah, it's a simple scaled code running service that doesn't require a whole computer. Hopefully that makes sense, and I can go even more in depth if needed. All righty. Thank you all for showing up, and we'll see you next week.